this lesson is about naming chemical compounds. You have to know about classification of chemical compounds. You have to know which category these different chemical compounds fit into, because the naming depends on the category. This is all called nomenclature. There are a number of different categories in this naming system for chemistry. And all of the categories have a different naming system. There are some similarities, but there are some differences for each one. So the first thing you've got to be able to do is to recognize the category. You probably in earlier classes learned a couple of these. You know, there's a different category for covalent and ionic, and there's a naming system for each. The naming system is a little bit different for those. So you've got covalent compounds, but in covalent compounds you actually have two different categories. You've got covalent that's non-organic and covalent that's organic. And those are different naming systems. There's some similarities, but they're different. Okay. Then we have ionic compounds. And I guess depending on your definition, there's about 3 different naming systems in that. It's really just you have to categorize certain parts of the ionic compound to figure out how to name it. Okay. I like to think of it as one naming system, but you might like to think of it as more than one. Okay. And then we have to learn to name the non-organic acids. Now the organic category includes some acids. So there will be some acids under the organic category that you have to name as an organic acid. So you have to go recognize when you have an organic acid and when you have a non-organic acid. Okay? So these are broad categories. And there are always exceptions. There are even some common names for things that don't really fit the classification system. But the classification system we're going to be using is set up by a group or an organization called IUPAC. And that's the International Union of Pure and Applied Chemistry. And they're the ones that come up with the accepted or universal naming system for chemical compounds or for chemicals themselves. They're the ones that come up with the names for the elements that are on the periodic table. They're the ones that decide when some group of scientists actually have created a new element, and then they allow that, generally speaking, they allow that group to name the element. Okay? With me so far? All right. So let's talk about the covalent nomenclature. And this is non-organic. For naming the covalent compounds that are not organic, you need to know some prefixes. Some of these I'm sure you're familiar with already. Di is 2. Tri is 3. Tricycle is a 3-wheeled vehicle. Tetra, 4. Penta, like the pentagon, that's 5. Hexa, that's 6. Hepta, that's 7. Octa, like an octopus, that's 8. 8 legs on an octopus. 9 is nona. And 10 is deca, like a decade is 10 years. So you need to memorize these. There's one little trick to this. So if the element before which you write this prefix starts with a vowel, you drop the A. You don't drop the I's, but you drop the A's. So if we have something that's a dioxide, we keep the I, but if it's a tetraoxide, we drop the A. It becomes tetroxide. So these prefixes, and these prefixes are only used for covalent compounds. These prefixes indicate how many of each atom there is in the formula. Now, in previous classes, you learned sort of a simple rule for identifying covalent compounds. The simple rule is, and there are always exceptions, okay, but the simple rule is covalent compounds will be combinations of nonmetals. So this identifying metals and nonmetals is a review from our Unit 2. We took all those periodic table outlines and identified those different regions of the periodic table. Okay, so if you have a periodic table of the elements here, okay, this stair step is the dividing line between metals and nonmetals. Nonmetals are over here, and everything else over on this side, those are the metals. Okay, so it's pretty simple. You have to look and find out where it is in the periodic table. Now, if you're taking honors chemistry, you're not going to have a periodic table with that stair step in it on the tests. So you have to memorize where that stair step goes. It's really pretty easy. You start right here between boron and aluminum, okay? And you start over, down, over, down, over, down, over, down. Okay, make a stair step. Does that make sense? Pretty straightforward, pretty simple. Just got to remember your stair step starts between boron and aluminum. All right, so let's do a few examples here. Let's say we have PCl3. Okay, so using this naming system, notice there's no prefix for 1. It's kind of like an algebra. Okay, in algebra, if you have 1x, 2y, you don't leave the 1 in front of the x. It's just x, 2y, right? Well, the same is true here. If there's only one phosphorus, we don't put a 1 in front, and we don't use a prefix for 1. All right, now, the prefix mono is rarely used, but there's one very common chemical for which you always use mono, and that's carbon monoxide. But that's the only time in this class that I can think of where we will use the prefix mono. Okay? All right. So this, then, we're just going to name the first element just what it is on the periodic table, and this is phosphorus. And then we'll pick the appropriate prefix to put in front of the second element name. And in binary compounds like this, the second element always has an IDE ending. Okay, so this is going to be trichloride. Okay, so Cl is chlorine. Cl is chlorine, and this becomes chloride because it's the second element in a binary compound. In a binary compound, the second element always has an IDE ending. Well, that doesn't apply to acids, but we'll get to acids later. Okay, so the IDE ending, IDE, applies to negatively charged monoatomic ions every time, and it applies to the second element in a binary covalent compound. Yeah, let's do one of those. Okay. How about P2O3? So this would be named diphosphorus trioxide. So remember, we only drop the A's in the prefixes when we start with a element with a vowel. We don't drop the I's. So let's see. Why don't you guys name this one then? Name this compound. Element names are not capitalized unless they're the first word in a sentence, or if you're using them in a title maybe. Okay, so element names aren't capitalized. Now, there are some compounds that have special names named for a person. We won't really get into that in this class. And that, if you're naming something for a person, then you capitalize it. But typically, these element names, they don't get capitalized. At least in the stock system we're using, we're not going to capitalize them, okay? Dinitrogen. Hexafluoride. Okay? So let me give you a name and let you write a formula for it. Okay? Try one of these. How about we do okay, write the formula for this. All right? Alright, let's look at nomenclature for ionic compounds. Alright, let's remind ourselves about where the metals and nonmetals are located. On the periodic table, metals are on the left side of this stair step, nonmetals on the right side. Okay? Metal and nonmetal combinations, or any chemical with a polyatomic ion, is an ionic compound. Okay? And there are always exceptions, but generally speaking, you can largely depend on this. Pretty safe bet. Okay? So we're going to start in part 1 with ionic compounds. That have metal cations. Remember, cations are positively charged ions with only one charge number, and that's the oxidation number we're talking about here. For ions, or monoatomic ions anyway, the oxidation number is the charge number. Alright, going back to the periodic table, let's remind ourselves of the columns of elements for which you already know the cation charge numbers. Alright? So except for hydrogen, because hydrogen generally is treated as if it's not a metal, all these elements have the same charge. And that charge is 1 plus. Or if you're writing it as a superscript on the symbol, it's just simply a plus sign. Column 2, 2 plus. Column 3B, 3 plus. This column here, the last column of the transition metals, those are all 2+. Mercury is a bit of an exception. It has a 1+ or a 2+ charge. And you'll have to memorize that. I'll give you a list of those later. Okay? In this column, they're all 3+. Okay? Now, those are the positively charged cations. Cations are positively charged. Those are the ones for which you should already know because of their position on the periodic table. Okay? If you don't know them, I suggest you go back and familiarize yourself with that because you do need to know that. Okay? So, compounds that have metal cations with only one charge number, you name the first element just the way the first atom by the element name. Okay? First atom is the element name. Second element in a binary compound will have an IDE ending. Okay? Metals of this type they're named according to their element name. In a binary compound, the second element has an IDE ending. Also, monoatomic anions, those are the negatively charged ions, monoatomic anions, have an IDE ending. Okay? So some examples. Sodium is in the first column of the periodic table. That's Na. So you just name it like the element. Chlorine is in column 7A because it's the second element in a binary compound, and because it's an anion, a monoatomic anion, we call it chloride. So this is called sodium chloride. Okay, so you name this. No prefixes now in ionic compounds. Pretty straightforward, pretty simple. Aluminum chloride. Okay? Let's see, how about I give you a couple of names and you write formulas for them, okay? Scandium oxide, write the formula for scandium oxide. You have to figure out by the charge and balance the formula. What's the charge on scandium? 3 plus. What's the charge on the oxide? 2 negative, unless it's oxygen is always going to be 2 negative unless we give it the name peroxide. Peroxides have a 1 negative charge. Okay? Oxides have a 2 negative charge. We want it to be neutral. Unless we tell you the charge on it, it's neutral. So scandium is in column 3B of the periodic table. All of those elements have a 3 plus charge. Oxygen always has a 2 negative charge. If we called it peroxide, it would have a 1 negative charge. But since we're calling it oxide, it has a 2 negative charge. I need a compound that's going to have a neutral charge. So I have a 3 plus charge here. I have a 2 negative charge here. I need to know how many of each of these I need to get a 0 charge when I'm done. So I have a 2 and a 3. So I need 2 of these and 3 of these. So I get a formula that's SC6. subscript 2, capital O, subscript 3. Scandium oxide. Try this one. Cadmium sulfide. So cadmium is in the last column of the transition metals, and all of those elements have a 2+ charge, except that mercury can sometimes also have a 1+ charge. But this is 2+, so that's C, capital C, little d, 2+, capital C, little d, 2+, that's cadmium. Sulfide, elements in column 6A, have a 2 negative charge in a binary compound. Also, since cadmium has a positive charge, I have to have a negative charge on the sulfur, and the only available negative charge on the sulfur is 2 negative anyway. So we're going to have sulfur 2 negative. Well, that 2+ charge and that 2 negative charge cancels each other out. So that's a neutral compound. I just have one of each. CDS. Okay? Yes?
So for like nitrogen, we just pick the one that works best with the element, because there's like 6 listed for nitrogen.
Well, but if it's in a binary compound, nitrogen is going to have a negative charge. Okay? If it's the second element, it's going to have a negative charge. Okay? So nitrogen, if it's the in an ionic compound, nitride will always be 3 negative. Part 2. So metals that have more than one common oxidation number. And for ions, the oxidation number is the charge number. Must have a Roman numeral to designate the charge. Roman numeral must follow the metal's name. It must be in parentheses, and there can be no space between the metal element name and the parentheses. All right. So here's an example. I'm going to try to name this compound. Iron has more than one common oxidation number. It can either have a 3+ charge, or it can have a 2+ charge. The common oxidation numbers of iron are 3+ and 2+. In this case, we need to be able to figure out which oxidation or charge number this iron has. To figure that out, we're going to look at the chlorine. Chlorines have a 1 negative charge. I have 3 of them. So that this compound can be neutral, the iron must have a 3+ charge. Okay? And so when we have more than one oxidation number or charge number for that metal, we've got to name it with a Roman numeral. Roman numeral is in parentheses. The parentheses must not be spaced after. There's no space between the name of the element, the metal element, and the parentheses. Okay, so it's iron 3 chloride. And we call it chloride because it's a negative ion, monoatomic, negatively charged ions, monoatomic anions always have an ID ending in their name. Okay? Does that make sense? All right. Let's review Roman numerals just in case anybody doesn't know what they are. So a capital I is the number 1. 2 I's, the number 2. 3 I's, the number 3. IV. If I was in a hospital, that'd be something they stick in my arm, but that's not what it is here. This is a number 4. Capital letter V. That's a 5. VI is 6. Capital V, 2 I's. That's 7. Capital V, 3 I's. That's 8. IX is 9. And capital X is 10. And you don't have to know any numbers beyond 10 for this class. Let's look at this formula. Oxygen is going to have what charge? 2 minus. I have 2 oxygens. So overall I have a total of 4 negative charges. I've only got 1 titanium. So what charge does the titanium have to have? It has to be a 4 plus charge, so we name it like this. Okay, write the formula for 10,4 chloride. Chloride has a 1 negative charge. There are 4 chlorines or chlorides, so those 4 1 negatively charged particles mean I have a total of 4 negative charges. So the 10 has a 4 plus charge, that balances it out. Okay? You got to have neutral compounds. Unless there's a charge on it or something that designates the fact that you have a charge on it, your compounds need to have a neutral charge when you've got it balanced. 7A is a negative 1 charge, correct. Everything in 7A. If it's the last element in the formula, well, I shouldn't say that emphatically, but almost always it's going to be a 1 negative charge. Okay? Mn is manganese, yes. You need to be careful about the difference between manganese and magnesium. Ionic compound nomenclature part 3. So you started memorizing polyatomic ions. Okay? When you name compounds that have polyatomic ions in them, you simply name the polyatomic ions just exactly the way you memorize those names. Okay? So all the other rules fit into that. So if you have a metal with more than one oxidation number, you have to have a Roman numeral. Okay, if you have a polyatomic ion, you name the polyatomic. You don't change the end of the names anywhere. You simply name the polyatomic ion. Okay. So if I have something like this, what would you call that? You have to be able to recognize that you have a polyatomic ion. What? Ammonium chloride. So when you're looking at this compound here, you should notice, we'll get to organic compounds next week, that there's not a series of carbon atoms in here. So this is a non-organic compound. And we have more than 2 elements. We have 3 elements here. You want to first thing you want to do when you see that little red flag should pop up, and you should say, okay, is there a polyatomic ion in here? And there is. This is ammonium. You name it ammonium. And then this ammonium has a 1+ charge. That means this chlorine is chloride. It's a negative monoatomic ion, so that's chloride. Okay? It's as simple as that. Okay? Let's try this one. Sulfate has a 2 negative charge, so for one copper and one sulfate to be charge balanced, to be neutral overall, the copper has to have a 2+ charge. Since copper has more than one oxidation number, it could be either 1+ or 2+, we have to designate which one it is with a Roman numeral. This is copper 2, that's what you call copper with a 2+ charge, copper 2 sulfate. Okay. All right, let me give you a name and let you write the formula, okay? Chromium 2 dihydrogen phosphate. Chromium 2 dihydrogen phosphate. You have to use a subscript to balance it out. Okay? So chromium 2 is 2+. Dihydrogen, oops. Back it up here. Chromium 2 is 2+. Dihydrogen phosphate is H2PO4 1 negative. I need 2 of these, correct? So I'm going to write that like this. Chromium H2PO4 subscript 2. Alright, anytime you have more than one polyatomic ion, you have to put the polyatomic ion in parentheses and the subscript after. If you only have one polyatomic ion, do not put it in parentheses. Okay? It's only when you have more than one polyatomic ion that you put it in parentheses and then put the subscript number afterwards to designate the number of polyatomic ions you have in the formula.